This video is going to cover the 2-sample t-test for a difference of means. So you have 2 independent populations, 2 independent samples, and you have a mean from each of those and a standard deviation from both of those. So here's a little snapshot of formulas, condition information. We're going to check our conditions on both samples. We're back to looking at this central limit theorem where n is greater than or equal to 30. And let's get started. According to a Stanford Business article, Americans may eat fewer calories at restaurants if the calories of the food items are labeled on the menu. To investigate this, researchers compared Starbucks receipts from locations where menus were labeled to receipts from stores where menus were not labeled. A random sample of 30 receipts from stores with labels had an average number of calories of 225 with a standard deviation of 100. So I kind of like to just write down the information I have here. So my sample for the labeled, the mean is 225, the standard deviation for labeled is 100, and the n for labeled was 30. A random sample of 40 receipts from menus without labels showed an average of, we'll use n for no label, 265 calories per receipt with a standard deviation of 75. And that was an n of 40 receipts. Is there convincing statistical evidence that the average calories per receipt at Starbucks with a labeled menu is less than that at a Starbucks without labeled menus? Assume conditions have been met. Okay, so we're not actually going to just assume conditions are met. We're going to do them all. But if that says it, then you can just say conditions are met. We can proceed. So we're going to do them anyways. So the first thing I'm going to do is choose my procedure. All right, so this is a 2-sample t-test for mu1 minus mu2. I have 2 independent samples, and I'm going to check for the difference in those means. My significance level, I'm going to let it be 0.05. It doesn't say, so that's usually our standard. Our parameter is the true difference in mean calories consumed for menus with and without labeled calories. Okay. Let's see, my hypotheses. My null hypotheses will be that the mean for the labeled minus the mean for the not labeled equals 0. And my alternative would be the mean for the labeled minus mean for the not labeled is less than 0. So if I'm subtracting them and the not labeled is larger, it's going to end up negative. And then what's my evidence for HA? It's that 225 minus 265 does not equal 0. So there is a difference of 40. So x bar L minus x bar n is equal to negative 40. And so we're going to check our conditions. Samples were random, so we can generalize. Okay, they were independent of each other because they were different stores, so we have independent random samples. That's important because that's why it's the 2-sample test and not the matched pairs. Our 100, not 100, 30, so it's in 10% of all Starbucks stores. Starbucks receipts. Forgive me if I don't spell that right. And 40 is also less than 10% of all Starbucks receipts. So we can sample without replacement. And then 30 is greater than or equal to 30. And 40 is greater than or equal to 30. So the central limit theorem applies. So we can use the normal model. And in this case, the T model. So my general formula, remember you don't really have to write down the general formula. It's helpful to remember that the T-score is the statistic minus the parameter, which in this case is our hypothesis, divided by the standard deviation. So our exact formula is x bar L minus x bar N minus mu1 minus mu2. This is our hypothesis, so this is going to be 0. And the standard deviation is SL squared over NL plus SN squared over NN. So let's put this in. Negative 40 is my difference, minus 0, divided by the square root of 100 squared over 30 plus 75 squared over 40. And we're going to put this into a calculator. Okay, so when you do this, you really want to leave off that minus 0 in the calculator. It's messing a bunch of you up. So we're going to do negative 40, and then square root of 100 squared over 30 plus 75 squared over 40. Okay, so I got a T of negative 1.837, plugging this in the calculator. Now I didn't bring a calculator home. So if you're plugging it in to the calculator, you want to do negative 40 divided by, and then the square root. If you do minus 0, it's going to do 0 divided by that square root, and you're just going to end up with negative 40. So make sure you then plug in 100 squared divided by 30 plus 75 squared divided by 40. And it should give you that value. So just leave off the minus 0. If you do, you need to put the negative 40 minus 0 in parentheses in the calculator. And then you're going to go for TCDF, negative 99. Negative 1.837. Our alternative hypothesis was less than, that's why we're using negative 99. And then my degrees of freedom is, we said, conservative estimate would be to use 30 minus 1, 29, or you can use 40 plus 30 minus 2, 68. So let's just do 29. Okay, I got 0.038. Now you can check your work by going into the calculator. If we go stat, calc tests, down to 2samp t-test. It's going to ask for x bar 1. That's the first mean. S1, the first standard deviation. So x bar 1 would be 225. S1 would be 100. And 130. Your x bar 2 is 265. S2 would be 75. And N2 would be 40. And then you make sure that you have the correct, it'll say mu, and then equals mu, less than mu, greater than mu, and you're going to choose less than because that was our alternative hypothesis, less than. Hit calculate. It should give you the same t and p-value. Now for our conclusions. Okay, so interpreting our p-value. Assuming HO is true, mu1 minus mu2 equals 0. Okay, there is no difference in calories for menus with or without labels. There is a 0.038 probability of getting our sample difference of negative 40 or more extreme pure. And in conclusion, because my p-value of 0.038, include the number, don't just say my p-value, include the number, is less than alpha of 0.05, I reject HO. There is convincing evidence and then we're going to use the sentence, okay? There's convincing evidence, average calories per receipt with a labeled menu is less than receipt without labeled menu. Okay, so you have, though, that the p-value is less than alpha. That means we reject HO and there is convincing evidence.